So first, thank you everyone for attending today's webinar. We're really excited. We are doing it in partnership with CloudWerx. And so I wanted to take this time to introduce our guest speakers. So starting with myself, my name is Jing She. I'm the Director of Business Development and Cloud Alliances at MemVerge, and I'll be your MC today. Siddhant, would you like to go next?
Yeah, thanks, Jing. Hey, Siddhant Gupta. I lead our engineering teams here at CloudWerx. We are a Google Cloud Premier partner. My background is mostly academic. I used to be a scientist, worked at Microsoft Research, have a PhD in computer science, a problem solver at heart, and really excited to be here and talk about MemVerge and CloudWerx. Thanks, Jing.
Great, John.
Hi, everyone. I'm John Jan, and I'm the CEO of MemVerge. I'm based in British Columbia, but our company is based in the Bay Area. So super excited to have the opportunity to talk to everybody and share with you some of our learnings over the last few years in the area of cloud.
Great. And Charlie?
Yeah, hi everyone. I'm Charlie Yu. I'm Director of Pre-Sales Engineering here at MemVerge. My primary responsibility is really talking to a lot of customers, deliver our solution, and help customer to get things up and running quickly. And so today I will be showing off some of the demos of our product, and look forward to the discussion. So thank you for having me here.
All right, great. So let's kick things off. Let me quickly go through the agenda and the timing today. I want to be respectful of everyone's time, and thank you guys again for joining. We're going to try to keep the formal presentation part of this to about 30 minutes, and then we're going to leave about 5 to 10 minutes for any Q&A. And I would also encourage each of you, if you have questions as we are speaking, please leave it either in the chat or the Q&A boxes, and we'll try to get to some of your questions as well in real time. We want to make this as conversational as we can over Zoom. So with that, let's talk about key bioinformatics pain points. I'm going to hand it off to John to kick us off into this section here.
Thanks, Jing. And this section, Siddhant and I will tag team, and but I'll just kick it off. So MemVerge was founded 5 years ago by our founders came out of academia as well as industry, right? And they are pioneer researchers in memory computing. And over the course of the 5 years, we've worked with the biotechnology vertical for the most of it. And we see that there's a trend in going to the cloud for bioinformaticians, both in the research, drug discovery phase, as well as in later phases of life sciences. We talked to many bioinformaticians, and we asked them what are some of the challenges they are seeing in using the cloud. So I wanted to share some of these learnings. First, this was a bit of a surprise for us. Even though the cloud is known for being agile, elastic, self-service, for bioinformaticians, often it still took quite a long time to get the resources that they need to run their workloads in the cloud. And the reason is that cloud is very complex, and we'll get into a bit of that in the next slide. And then once their workload is running in the cloud, there are other issues that they face. This OOM era happens more often than I had expected, right? And when a workload runs out of memory, very often they have to restart their workload, and then precious time are wasted, as well as cloud cost, right? And then the other thing is that a lot of the pipelines that bioinformaticians or scientists run require a large amount of resources, large number of VMs. And very often, a priori, the user doesn't know what kind of resources are required, right? So I think we'll get into each of these scenarios a little bit more. So let's go to the next slide. Bioinformaticians, I've learned, are a super talented group. They really need to know biology, they need to know genomics, they need to know computer science. And so it's an interdisciplinary type of position. But in general, DevOps or managing the cloud is not part of that job description, right? And we all know that cloud has become quite complex, right? So in Google Cloud, there are hundreds and hundreds of different machine types that you can use to run your workload. So it is quite difficult for bioinformaticians to do that themselves. So they typically would rely on cloud admin or different IT organization to do that for them. And I think that is the crux of the reason that it takes so long and takes so much effort to get access to cloud resources. So Siddharth, I know you work with a lot of the same users. Maybe you can share some of your experiences as well.
Yeah, absolutely, Jonathan. This is the same story. And I can share a personal anecdote. I've come from an academic background where we did not just have money to throw around, right? And then you're trying to figure out how to optimize, how to run this. And I would say 50% of our job wasn't the statistical analysis, which is really, as a scientist, what you're trying to get to, a breakthrough in any discipline, but rather what computer is going to run on, can I leave it overnight? Is it going to crash? If it's going to crash, is it going to restart? Tooling. On the flip side, I've also worked in corporate environments where, and I'll put it lightly, but like money is no object. Like I am not paying the cloud bill and I have no idea how much it's costing. And so I can now throw these on massive machines and make magic happen. The latter is not a reality once you start actually working towards a product, get out of the R&D space, and you need to start thinking about where are your computational pipelines running, right? And so you really hit the nail on the head. Cloud is complex. Well, someone can argue, no, it's easy. I can click and get a VM going, and that's great. Yes, that's the power, is you can have 10 PCs at your disposal, but how do you orchestrate them? How do you make sure they are cost effective? Case in point, with CloudWerx, I said, we're Google Cloud Premier partners. My day job is knowing Google Cloud inside out. And I can tell you, I don't know the number of SKUs that exist for just VMs on Google Cloud. I think it's upwards of 400. Every time I've tried to load that list, my Chrome tab crashes because the list is so long. It takes so long to load. So the larger point here is, as a bioinformatics individual, scientist, researcher, you are pushing the boundaries of science, knowledge, and you want to get to an end result, not figure out what is the cheapest VM and the best mechanism to run your workloads on Google Cloud or any of the other clouds. And to me, Jonathan, that's really the crux of the problem. How do you take the IT and the DevOps out of the job function of a bioinformatics person?
Right. And another very simple example is research showed that a lot of cloud waste happens, right? Because people finish their job and then let's say the job finished in the middle of the night and they don't get up to turn the machine off, right? And then that machine sits idle and the bill keeps running, right? So simple things like that create a lot of inefficiencies. So let's go to the next slide. Another point I made is bioinformatics workloads consume a lot of resources, right? And we have also tools such as Nextflow that manages pipelines that could generate hundreds, if not thousands, of jobs. So in the slide, this is a actual customer that we worked with. One of their pipelines generated over 11,000 jobs in the cloud, right? And it's virtually impossible a priori for the user to know what kind of resources they should give to each of these 11,000 jobs, right? Because these are automatically generated. And so what ends up happening is they use a default machine size and hope for the best, really. So what happens is you have, because each of these 11,000 jobs may have different resource requirements, you may be over provisioning or under provisioning. And either case is inefficiency, right? So that's another example. And then I want to share the third example. Go to the next slide. For a lot of the workloads, each job could have peaks and troughs, right? Because utilization is always bursty. In this particular example, this is, I believe, blast. So in the beginning of the job, there's a peak in CPU utilization because the job is setting up, it's setting up the database, and then there's a lot of I/O, and it basically prepares the database for operation, and then there's a second peak where it loads the user data to do comparison, and then the CPU utilization actually tapers off. So what happens here is typically the user have two choices. They can start with over-provisioned machine that can handle the peak usage, in which case most of the time the machine is underutilized. Or they can use a under-provisioning case where they provide small amount of resources, in which case it takes much longer. So in this case, the customer did the experiment for this workload. If they use the 32 vCPU machine, it takes 11 hours and 44 minutes to finish. If they use the under-provision case, 16 CPU machine, it takes about 6.5 hours longer, right? So, and these things happen during the middle of the run. So it becomes virtually impossible to basically optimize the efficiency for situations like this. And that is one of the hard problems that we are also aiming to solve. Okay, so Siddharth, anything to add before we talk about spotting?
Yeah, I was gonna say this is such a wonderful diagram. You know, we literally have a part of our business called FinOps, where we help manage and reduce cloud costs, right? We are able to do that for workloads that aren't like this, like bursty, unpredictable. These are like our customers running web apps, services, SaaS software. We're able to come in, look at historical, and then right size the VMs or the compute for them, right? But it is nearly impossible for us to do that for something like this, a bursty load. Now, yes, sometimes if certain workloads are running in something like Kubernetes, it is, you know, you can handle it. But for most part, any of my customers who are running batch jobs, this is an everyday problem. And I don't have a solution to fix it before I met you guys and we've learned about MemVerge, right? So I have 3 biotech customers. And yes, they are over provisioning because time is money, you know, time to market is important, but then they're spending so much more on underutilized, unutilized machines. They tried using SnakeMake with containers, but again, their team is starting to become a DevOps team, and they ask me questions on Slack, which I'm like, yes, I can explain it to you, but then it takes me 40 minutes to explain it to them. And then they're like, it's a waste of time because I'm a scientist. Why am I doing this? So this is such a wonderful example and why I've started recommending MemVerge to our customers.
Great. Okay, and there's one last thing. It's Spot VMs, right? So Spot VMs are VMs that you can get at a small fraction of the list price, right? And the reason that they are so inexpensive is that it's fulfilled using excess capacity by the cloud. And there's a catch, which is when the cloud needs to use that capacity, it will take it away from you with minimal notification, right? So, so it's a great way to try to save cost, but if the application is not able to handle that type of volatility in the infrastructure, then you wouldn't be able to use it. So for a lot of bioinformatic workloads, that is not a good infrastructure, right? So because these workloads are stateful, meaning if it's interrupted in the middle, typically you need to start from the beginning again. And it's long running, which means there's a higher probability that the Spot instance would be preempted by the cloud. So that is also a big issue because cloud cost, as it turns out, could be quite high, right, for a lot of customers. And Spot is probably the most direct way to save money, but then it's not compatible with the application. So again, another problem that we want to address. Okay, so Jing, I think next slide is, that's my last slide, right? Okay, so let me, so Siddhant, before I turn it over to Charlie and Jing, any other comment on Spot?
Just the last comment that the issue you're addressing with running stateful, non-preemptible jobs on preemptible VMs, Spot VMs, is, I think, the magic sauce here. That cannot be said enough how amazing that is. Preemptible VMs are like, if you don't care about what happens middle of your job, run it. That's how it's being used, and that's how it's priced. But you're able to run stateful jobs that should theoretically be running on normal VMs, but you're able to take the price of a Spot VM. So I feel like that's where the magic is, and everybody should pay attention to that. That's the takeaway.
Thanks, Siddhant, and that's why we're so excited. So, Jing, let me turn it back to you.
Sure, and I have maybe one more insight to add as well, and this comes from working with both companies that are in the private sector as well as companies that work in the nonprofits and are and work based on grants. You can do things like reserved instances. You can commit spend, but it's very difficult to do that in a calendar year because what we find is many research teams, and especially nonprofit research organizations, they work on a grant cycle. So sometimes you might need a lot of compute, but you might only need it for 3 to 6 months. And so that presents this really tough scenario where you're either having to run everything on demand, or you have to have a team that understands how to utilize Spot. And again, this is a very exciting thing that we're doing because we're enabling you to use these types of VMs without having to have that team in place in-house. We do it through our software. So with that, I wanted to transition to Charlie. We're going to do a really brief overview and also walk you guys through the product. You can see how it works and what it looks like. So Charlie, I hand it to you.
Okay, sounds good. Let me share my screen.
Oh, okay. Did you want to share your screen right away? That's fine. I had 1 or 2 slides if you wanted to quickly introduce the the product and
okay.
And
yeah, sure. So the product itself actually runs in your VPC, your virtual private cloud. Whether you're on Google Cloud or on AWS, they both support it. You can find our software in the marketplace, and it's very easy to install and then deploy. Like what we talked about earlier, our goal is really help you to easily deploy workload in the cloud without having to have a lot more things to worry about. So let me share my screen and then show you what exactly that looks like. Okay, so with our software installed, what you will see first thing is this GUI, right? This user interface, and this GUI actually runs on one of the VMs in your VPC. So that's kind of how that works. And we have the tool to help you easily deploy any workload that you choose, and as to which one you can pick and choose from, that is determined by the image. So over here, you have a lot of applications that you can deploy. A lot of it in the bioinformatics, but we also run, we also allow customers to run things like Jupyter servers, RStudio, and all that. These kind of IDE type of applications as well. And you can get a full, sorry, you can get a full list of them from the tab under App Library. And you can see here, these are the built-in apps. But if there's any of those you don't see, you can just simply come over here under private and add a new image, and then you can add a new Docker image, whether that image is on your local laptop or somewhere on the Docker Hub. You can easily add that to the app library. Once you have that app library added your Docker image, the next thing is to submit a job. So simply giving the app name, the image, the job script, which how you can specify how you want to deploy the job, amount of resource, CPU, memory, storage if needed. You can also specify the whether you want to run on demand or on spot. With that filled out, you can submit the job, and then the job will kick off and then running. So I've been running a few jobs from earlier today. This was from like a little over less than an hour ago. And you can see here, this was a Spades job, right? So the application is Spades. And under WaveWatcher, we allow customer to get a pretty good idea on how this job ran throughout the whole time, right? Because these are the spot instances, these are not guaranteed. So at some point when the job was running, it could get reclaimed. And this is the behavior of what happens when the instance gets taken back from the cloud provider, like GCP. You can see here, we essentially zoom in looking at the job level of this VM, and we can show you how much memory is using, how much spot space used, or buffer cache. And so it's running fine for a while, but at that one point, it gets reclaimed. So during this time, the VM is no longer available, and we actually took this job that's running on the first VM, and we rehydrated into the second VM. So everything continues onward on the second VM without losing progress. Right? That's really the key. Because if this job ran for, let's say, 5 hours, and at some point gets reclaimed, without this capability, you will have to restart from the very beginning, which you will lose 5 hours of time, right? But with SpotSurfer, that's the name of our feature, you can continue to run onward until finish. And it doesn't really matter, it gets interrupted, reclaimed once, twice, 3 times. We can easily protect the life of this job, and it will finish at the end without any lose any progress. Okay, so that's one example of this. And the second example I kicked off earlier is another way of using this is through a feature what we call the WaveRider, right? Because when we launch a new job in the cloud, it's really difficult to figure out how much resource do we really need. Do I need 4 CPUs, or do I need 12 CPUs or 16 CPUs? And that decision is very important, because if I allocate not enough CPU memory, or not big enough VM in the beginning, I can easily run out of memory, and then my application will crash, right? And that's the out of memory situation we were talking about. But on the other hand, if I allocate way too much, right? If I use a VM is much bigger than what I really needed, then we're essentially wasting a lot of the cloud resource, and that is very, very expensive. So with the WaveRider, we basically are able to resize the VM at runtime, right? So this example here, again, this job I only kicked off about half an hour or 45 minutes ago. So you can see here, the application initially wasn't using a lot of memory, maybe a gig, couple gigabyte of memory, and then using maybe 2 CPUs out of 4 total, right? About 200% out of 400%. And this was on the 4 CPU VM, 16 gig memory. And and then when the memory runs out, our software was able to automatically upscale that to a VM that has 32 gigabyte of memory. Same amount of CPU, but more memory. And then it kept on running for a while, and it reached the upper limit again. So we scaled up to an even bigger VM, right? This was a CPU, 64 gig of memory. And then when that is not enough, it scaled to something even bigger, right? This was a 16-core, 128 gig VM. So it's able to do that without any user intervention. And then all you have to do is just kick off the job and then let this thing take care of itself. And that's what's really the power of the WaveRider, allow you to automatically right size the job.
So
And
let me just interject here one point. One thing that you also get as part of this is the protection against out-of-memory error, as I discussed before. So WaveWatcher will detect that the application is running out of memory, and before it crashes, it will suspend the app and move it to a larger machine where there's enough memory. So you get that as part of this.
Yep. So so this job is actually still running. So you can see here is still executing. I can show you what the entire job from the beginning to the end looks like, right? So after the job reached its peak workload, it used a lot less over the next few hours. In fact, it used only a fraction of what it was using at the peak time. And our software was able to also downsize the VM to a smaller machine, right? And depending on the duration, we can keep downsizing until at the end it was sitting on the machine that has only 2 CPU and then an 8 gig memory, right? So that's really the capability that we can provide to be able to resize the VM very easily. And then we can do that because of the in-memory snapshot technology that we built, as we said many years ago. Moving a job from VM to VM is very easy for us, and it's very capable in our stack. And then we've been doing this for a very long time. So we feel confident about the technology, and we want you guys to try that out. And then you'll be very intrigued on what we can do to your current workloads. One last bit of word I want to mention is we are currently in beta phase for GCP. So you can actually find our software here once it's fully GA'd. But you can type in MemVerge in the search box and you can find our software here. And once you installed the software from the cloud, you will get something looks like this. It will say something called App Center, something with some digits, and you can access the GUI from the IP address. Okay. So with that, I will turn that over to Jing, and then we will continue on with the presentation.
Great. I know there's a few different questions, so maybe we can take this time to answer a few of them. I was in the middle of typing another one in the chat, but I think Rob asked in the Q&A, can the user customize which instance types are instantiated when WaveRider saves a job from the out-of-memory error? Does anyone want to take that one? John or Charlie, maybe?
Yes. So in a queue, oh, can I, I have it on different screens.
Yeah.
Yes, so you can always specify the instance type that you want to use for a specific job.
Mhm.
You can also provide policies on what type of instances that this job can wave write to. So for example, you can say, I only want to use Intel CPU VMs, right? Or you can say, I only want to use these, I only want to pick instances out of this list of GCP instances. And so the software allows you to specify these policies, and we will run within these constraints.
Great. And Slava just answered your question around, can we support proprietary software? We have started to, and MATLAB is a good example of that. And I guess the best answer is it depends. So if you have specific applications, let's take a look at how we can support them. But in general, if you can containerize the application, then we should be able to run it and manage it for you. John,
Yeah,
would
but
you
I
like to
think
add anything else?
Slav's question is on licensing, right? So, so if the license is node locked, meaning you can only use it and lock it to a particular type of a particular MAC address or IP address, then I think we need to have some special treatment for WaveRider and SpotSurfer, because when you WaveRide or SpotSurf, you're getting a different machine, right?
Yeah, we have to go talk to the vendor together.
So I mean, there are multiple ways you can get a different licensing scheme if the software supports it, or we'd need to, like, if it's locked to a particular IP address, there are probably things that we can do to get to use the same IP address for different VM instances. But in any case, these are special configurations that we'll need to do, to support that licensing.
Great. Yeah, great questions, everybody. Keep them coming, and we will continue to tackle each one as they come. But perhaps we can move on to the last part of our talk today, and it's really, how have we been working together with CloudWerx? And so maybe I'll kick this off, and I'll also do it together with Siddhant here. Siddhant, would you like to start, and then I can?
Yeah. Absolutely. So what you all saw is the magic of MemVerge, right? And somebody asked, hey, what is the software? Where is it running? And then Charlie also showed you the marketplace search box, and then it brought up MemVerge. So that is where kind of CloudWerx comes in. We are highly skilled at Google Cloud, and that's all we do. Yes, our engineers know AWS and Azure because we cannot work in isolation. But our company's focus is particularly Google Cloud. So when Jing and team, decided they want to be on Google Cloud Marketplace, of course, you can go try and read the documentation, then ping somebody at Google, and so on and so forth. Where we came in is we are subject matters expert when it comes to Google Cloud. We have a full program around marketplace listing. So we took it off the MemVerge's plate and said, we'll get you spun up on Google Cloud ASAP. We'll walk you through the marketplace process, so on and so forth. Now, as a customer of MemVerge, what's really amazing is if you're going to be buying this product, particularly MemVerge, from Google Cloud Marketplace, it obviously implies that your VMs, your billing, your operations are on Google Cloud. And so outside of MemVerge console, as you're getting set up on Google Cloud, as you want to explore discounts, if you're going to be using MemVerge a lot and spending a lot of dollars, Where CloudWerx can come in is show you techniques, and Jing touched upon this a little bit with Cloud Commits, is how you can apply your discounts and Cloud Commit dollars to actually purchasing MemVerge. Beyond that, if MemVerge is not the only product you're using and you're doing something else with Google Cloud, such as you're using Workspace, you have a Kubernetes cluster, or you're using it for storage, you want to explore healthcare APIs because you're in bioinformatics, that is all of work that CloudWerx does and can consult on, can even do hands-on keyboard work. That's actually our bread and butter. And if you don't want hands-on keyboard, you simply want a trusted partner, MemVerge and CloudWerx can come together, set you up for success, take care of it. If you have any support questions, MemVerge support questions will automatically go to MemVerge. If you have any Google Cloud issues, those will come to us. If you run into any problems, MemVerge will work with CloudWerx on the back end to make sure that your operations are smooth. So really, it's a three-way partnership. You get the best of MemVerge, you get a trusted partner who knows Google Cloud inside out, and not just with MemVerge, but beyond. If you're having trouble on Google Cloud, we can help you there. So that's kind of where we come in. Particularly for MemVerge, it was getting on Marketplace and ensuring that MemVerge's own team is really competent at Google Cloud.
Great. And just to add to that, I mean, it was very helpful. It freed up a lot of my time to be working with CloudWerx to get MemVerge Memory Machine Cloud supported on Google Cloud. And I know our engineers have been really thankful as well for the support in moving to Google Cloud support as well. So it was a great experience all around, and we saw that CloudWerx also had experience working with customers in the life sciences space as well. So they totally got our product right away, understood how we needed to understood the value that we're providing, and also understood our customers. And so I think for many of you here on the webinar, coming from this vertical, you're working with two different partners that are complementary and understand your space from each of our respective angles.
Yeah, and for special configurations like the previous question, we can work with CloudWerx to address what's needed, right? And we can tailor the Cloud implementation in your environment according to what you need. Yeah.
And Slav has a question that and by you, I mean, it could be either CloudWerx. Yes, we can absolutely help. So particularly MemVerge will have to assess whether that application is even amenable to being containerized, if it's highly specialized, and if it is amenable to being containerized, will it play nicely with MemVerge, right? Where CloudWerx can help is will work in the background with MemVerge if this container isn't operating as it should, obviously as designed. Yes, we can debug. Another thing could be if you need a little bit more dev hands-on keyboard, and Slav, you or your company becomes Google Cloud customer. As partners, we have access to what's called partner service funds. So that is basically Google subsidizing development work for you. So we can tap into that and work with the MemVerge team to accelerate that Dockerizing or customization, especially for you. And that is unlocked by you being a Google Cloud customer, working with CloudWerx, and then CloudWerx going on your behalf and tapping into dollars, resources, credits, discounts, etc. And then we can apply those to MemVerge's team and work together with them to get you onboarded on both MemVerge and Google Cloud. So yes, long story short, we love finding creative, both financial solutions as well as technical solutions. So yes, ping either team, and the three of us can hop on a call and figure something out.
Great. And yeah, that I think this we're getting towards the end of our formal talk here, and just to kind of wrap things up, MemVerge is delivering Cloud Automation 2.0 through our Memory Machine Cloud solution. And with that, you get to run on Spot instances safely, and without the need to have a specialized team who even understands how to use Spot instances. you get, we actually have a savings guarantee, I'll say it that way, which is that if we cannot save you 60% off at least versus doing these things with on-demand instances, you don't pay for our software. And in general, you don't pay for our software unless our software is already saving you substantial amounts of cloud spend. That's just our model. You can see it in our homepage. And also, this concept of needing to know what types of VMs you need, especially if you're coming from an on-premise work environment or HPC on-prem environment, we can help with that through our automated right-sizing WaveRider capability. And ultimately, we're trying to give you back more of your time to go do your science. So I wanted to thank all of you for staying with us through the prepared part of the presentation. We will stick around for a few more minutes if any of you have additional questions. Thank you all for attending today. And thank you to our speakers.